once you have more than one kid. It's just been being like, be nice to each other. Stop fighting.
My mom was Bentley, don't climb on that.
Bentley, yeah. Don't climb on that came up a lot in my house too.
Don't climb on that shelf. It's going to fall on you. No, it's not.
And then bam.
It's time for bed.
I like your impression of your brother in pain and sad. Mom. All right. So today we're going to talk about stoichiometry, which again is just working with chemical equations and putting them into the real world, but then doing so with solutions. All right? If you remember, we did that with non-solutions, right? With just like physical amounts. But today we're going to do lesson 4.6, stoichiometry of solutions. And I'm going to use a black pen. That's better.
You have the unfinished part up at the top.
Yeah, that can be fixed at my leisure. Okay, so I'll give you a minute to get your out. I don't know, some people are pencils, pens, quills, feathers, inkwells, mechanical pencils, pencil crayons, feathers. I hate crayons too. I love the idea of crayons, but man, do I hate crayons. Immediately dull, immediately impossible to draw with, always breaking, always everyone there. But
sharpen them, it's really uncomfortable.
But I do love like how they like. I love crayon art. Like I do think it's kind of really beautiful, but pain to work with. As a kid, I wonder if it's still there, but there's this very particular kit of like pencil crayons that also came with like a pencil and eraser and like a little math set that I would get for school every year from like Zellers or Kmart or something. That was always like my sign of the new year was like my new pencil crayon kit.
There's a lunch cafeteria thing with a chocolate milk prize.
Yeah, you get like a ballet and then like you have a chance to win a free meal.
Yeah, that.
No.
Yeah.
Well, there is. I'm actually the one that's doing the announcements of that. At the end of the.
And what's going on? What do I need to do something?
You just go.
Did I miss an email?
Buy like 5 large chocolate milks.
Okay,
you might win a free
in like
meal.
they have this like prize thingy.
Yeah.
So if you buy chocolate milk, you get to write your name on this stuff.
Did Pouliot order too much chocolate milk? Is that what's going on here? He's like, crap, I ordered all this chocolate milk. What am I going to do? Well, gotta do a prize.
And then you get as many chocolate you buy as how many chickens you get, and then they rally it. Or they have this ginger roll box.
Oh, that's fun. My dad wins like ballot things all the time. Like whenever we go to like every year, like there was one for like my son's like hockey, like Kiwanis League, they'd always do like, those like you drop your name in the, like you get a sheet of tickets, you drop your ticket in and you see who wins. Or like 50-50 raffles, like at my daughter's like dance things. He always won something. And I have never, ever. It's weird. Yeah, maybe. I mean, maybe he's just like paying off to let you be like, hey.
Man, I like the dad's root beer that they have here.
I like dad.
I feel like an alcoholic.
Moving on. So let's get to it.
At the end of the announcements, you'll hear.
Like today.
Yeah.
Did you do it yesterday too? I wasn't here, but
Yesterday, the day before. It's not as class. It's just like right before.
Like before lunch?
No.
Before the end of the day.
Yeah. So
Oh.
2:07.
Oh, yeah, because I don't have a class. I'm often not paying attention, but today I will pay attention. Okay, so. Okay. Okay, let's focus. So, Chemical reactions often involve solutions. No, you're good. Are you kidding? So, what do I mean when I say chemical? This just when the class is small, it feels weird to stand in front of you. You know what I mean? That's like my preferred position at the lectern, but when it's a small group, it always just feels like, why is this doofus standing?
It's like a recipe.
Yeah, exactly, right? Think of our displacement labs, both of them, right? In our displacement labs, we were working with aqueous solutions, right? Just an example, but at one point we were taking, say, magnesium ribbon, which was a solid, but we were adding it to copper chloride, copper 2 chloride. That wasn't a solid, was it? Like when we did that lab with the little ink wells, this was a solid and this was dissolved in water. If you remember the copper chloride, it was a blue liquid, right? And when it reacted, how would this react? What kind of reaction is this going to be?
Single displacement.
It's going to be a single displacement. Very good, which means what's going to happen?
Magnesium is going to replace with copper.
Very good. So what'll be by itself over here?
Copper.
Very good. And then magnesium is going to end up with chlorine. Magnesium has how many electrons to give away? And because every chlorine can only take one, how many chlorines do we need then?
2.
Yep, so it's going to be MgCl2. And if you remember that, copper was a solid, but did we also get like a big dumb rock forming in there, some crystals forming? No, and because all chlorides, in fact, are soluble, it was aqueous, right? So why do we mention this? Well, what we mention this is that like we had a solution here, which means that this would have a volume and a concentration. Does that make sense? So let's do this. Let's say, I'm going to say lots of magnesium. In other words, we have more magnesium than we need. In other words, it's not going to run out. If lots of magnesium is placed in a 0.20 liter solution of 0.85 molar CuCl2, what mass of copper will be produced? Okay, I'm going to get that written down. Make sure you have the equation up above. I don't want to be in a rush here. Got nothing but time. Fie on you, Orlando.
No.
Pish posh.
My hands.
Like that. And for this, I kind of want to remind ourselves of my little roadmap, all right? Because what we want to go is from like either, we actually have two things. right? I've been given two pieces of information, right? I have 2.2 liters, which is 200 mils of this stuff, whatever it is, of the what is it? Copper chloride. But that copper chloride has a concentration of 0.85 moles per liter. Does that make sense? Two pieces of information. And from there, we want to do some stoichiometry. Now, I think Alastruck teaches this with a little bit of algebra. He teaches some formulas and has them sub in and solve, and then a second formula and they sub in and solve. There's nothing wrong with that. It's not how I teach it. It's perfectly an entirely legitimate way to teach this. Does that make sense? But I want to say I still do this with dimensional analysis. But what I'd say is we're starting either with the volume of this solution in liters, right? Or the concentration in moles per liter, right? Doesn't matter which one we start with. What do we want to know at the end? It's asking us to find what? What?
The mass.
Mass. And the mass of what? Because this is CuCl2, right? But we want to know the mass in grams of what?
Solid copper, which is just Cu.
Of just copper. Good. So we want to know what's that pathway look like. Well, for that, I'd like to remind you of our kind of map here, which is if we know how many moles of A we have, what can we figure out? Well, we can figure out how many grams of A we have. Of course, we could figure out how many moles of something else we have, right? Moles of B. And from that, we can figure out how many grams of B we have, right? Does that all feel comfortable? I've done this a lot, right? But does that feel like a reasonable path? I could put number of particles over here. I'm not even going to bother today. Does that make sense? Because we don't do that very often, right? Remind me quickly, if I go from grams to moles or moles to grams, where do I have to look?
Periodic table.
Great. So that'd be true here as well. If I go from moles of one thing to moles of something else, where do I have to look?
Balanced equation.
I have to look at the balanced equation. Good. But then we have this other bit, and these kind of live together. So I always just kind of draw them right next to each other, which is these other two things we could know. We could know how many liters of solution we have, or we could know the concentration in moles per liter, right? Right? We could know the concentration, or we could know the volume, right? And likewise, if we can do that for A, then we can also down here find the volume of the solution, which actually should be the same as that volume, right? Because the volume doesn't actually depend on what's in it, right? It just depends on... That says solution, and I'm not even going to bother. I'm just going to erase that and just put L. Just volume, right? And the concentration, which would be how many moles of B there are per liter. And the reason I draw these right next to each other is because they're related. If you know one, you can always find the other. If you know the volume of the solution and you know how many moles you have, well, then you can figure out how many moles per liter. Does that make sense? And if you know the concentration of B, does anyone remember that if we put things in square brackets, we mean the concentration of in chemistry? If we know the concentration of B, well, then we can find its volume. And if we know the concentration of A, we can find the volume of the solution. And if we know the volume of the solution and how many moles we have, we can find its concentration. So this ends up being our big kind of roadmap here. Does that make sense? Well, in this case, we're going from here, one of these two things, and we want to get to here. Does that make sense? Well, that's not so bad. But it does beg the question, which one of these should I start with? Well, if you remember, I asked the good old question, fraction or not? The unit, grams. Is that unit a fraction or not a fraction? Not a fraction. Okay. What about liters? Fraction or not a fraction?
Not a fraction.
Okay. Molar really stands for, yeah, because it really stands for moles per liter, which is a fraction, right? So the answer I'm looking for is not a fraction. So which of the two pieces of information that I know to begin with, the volume, which is not a fraction, or the concentration, which is a fraction, should I start this math with?
The volume.
Yeah. Again, you could actually do it with either. Both will work mathematically. This trick just helps make your math easier. Does that make sense? So I'm going to start with volume in liters, and I want to get to grams of this other thing. What's my path? I'm going to go from liters to moles. What am I going to have to know to make that happen?
The concentration.
Good, no problem. And once I know how many moles of A I have, where am I going to go to get to grams of B?
The balanced equation to go to moles.
Yeah, I'm going to use the balanced equation to go from moles of A to moles of B. Beautiful. And then finally, from moles of B to grams of B, what am I going to do?
Use the periodic table.
Does that make sense? And that's our pathway. Not so bad, right? So let's look at that. So the path is actually going to be start here and go from liters of A to moles of A to moles of B to grams of B. Does that make sense? That's our pathway. Shut up. Oh my goodness. I am so sorry, guys. I'm just going to put this on Do Not Disturb because my phone is like freaking out.
Have you ever
Oh,
thought
it's
about
just
getting
my-
like a custom ringtone?
No. All right, can we try doing the actual math here? What is the volume we're started with? We're told in this case we're going to start with how much liquid? Yeah, very good. And what's the unit on that? Yeah, beautiful. All right. And of course, when we do dimensional analysis, the first thing we're going to do is multiply and draw a fraction line. And without thinking, what goes on the bottom here?
Liters.
Great. And then we look at what our kind of pathway is. And we say, okay, from liters, I'm going to go to moles. And moles aren't just random moles. It's got to be something. The green that I've highlighted, the solution, that was moles of what?
CuCl2.
Yeah, the copper chloride. So I'd say moles of CuCl2. Now I need to know how many moles are in a liter of CuCl2. Where do I look for that information? Concentration, which has to be given to you, right? Unlike when we look at the periodic table, that's always the same, right? But the concentration can be anything, right? It's whatever solution you're actually working with, right? Does that make sense? Well, in this case, what solution are we working with? How concentrated is it? It's got to be given to you if you're going to go from volume to moles. But I gave it to you in this question. What's the concentration? I also highlighted.
0.5.
Yeah, 0.85 big M. And again, that big M means molar, which means what? It means the 0.85
Moles per liter.
moles in every liter. Good. So where's the 0.85 go in this fraction? The top or the bottom?
Top.
Good. What goes on the bottom?
Yeah.
Yeah, very good. Because the concentration is always how many moles are in 1 liter. What units cancel here? Sorry? Very good. So liters will cancel. If I were to stop calculating now, what would I know? Yeah, I'd know how many moles of CuCl2 I'd started with. But of course, we're going to carry on. So from moles of A, we want to get down to grams of B. Where do we have to go in the middle? What's our pit stop? From moles of A, we go to... Good. So how do I put that here? In this case, what unit goes on the top? What unit goes on the bottom? Okay, and what is A in this case? Oh, not the number. No numbers. Because, of course, we know where we'll get the numbers. Where will we get the numbers? Yeah, but the stuff. So the stuff that's going on the bottom is moles of what? What are we trying to cancel here? What don't we want to talk about? The copper chloride. And actually, the question wants us to talk about what? What mass of solid copper? And how do we say that? Just moles of... Very good. Now, from this equation, I picked a very boring equation. In fact, there's no numbers in this equation. How do I put numbers into this fraction when there's no numbers in this equation? Of course, the fact that there's no numbers here means that what number is actually in front of each one of these? Yeah, that's right. One of these reacts with one of those. Give me one of these and one of those. So what numbers go on the top and bottom of this fraction then? Yeah, 1 and 1. I picked a question with easy stoichiometry to start. And then finally, what units cancel? Well, yeah, but right now what units cancel? Sorry, I should have asked. Yeah, so what unit would I have? What would I know if I were to do this math? 0.2 times 0.85 divided by 1 times how many moles of copper? And then the last piece of the puzzle is I don't want moles of copper. Where do I put that? Instead, I want what? Grams of copper. And where do I find that information? My newly mounted periodic table. Only took me 6 years. So that's pretty good, right? I did the fancy way with green twist ties. Like a pro. Like a friggin' pro. What is it? 63.546.
Land is weird.
Right? No kidding.
Yeah.
And how many moles are we talking?
Not for that, but like for the answer.
I know. But when we get there, how many moles are we talking about here? Why 1?
Because we're saying like that for 1 mole there are 63.546 grams.
Beautiful. Yep. Great answer. And of course, whoa. Hey, you. Moles of copper will cancel. And so the unit that remains is grams of copper, right? So now let's do this math, shall we? Really quickly, 63 times 0.2 should be like 10, like 12, right? Like 12.7, right? Or is it like 17? Let me think. No, 12.7. And then we want like 0.85% of that, so 85% of 12.7, which is like more than 4/5. We should be talking like right around 10. Right around 11. Yeah, okay. Oh man, right at the end of yesterday's lesson, I had a real stinker one where I was way off, and I was really embarrassed. I was like, should I go back and refilm that? And I was like, nah, that's okay. Let my shame fly. Anyway, was it 10.8? 10.80. Now, of course, we'll put all those down there, 10.80, and then we'll figure out our sig figs, the sig figs of it all. But first, let's get that down, 10.80. Give me a couple more digits if we got them. Great. Okay, so we got that. And our unit, obviously, is grams of copper. Now let's, talk sig figs. How many here? 2 sig figs. And here?
So 2 is going to be the least.
I think so, yeah. How many here?
Infinite.
That's infinite because it's definitional, right? When we say moles per liter, we mean exactly 1 liter. And this comes from a balanced equation, which is about counting, not measuring. So they're infinite. Don't have to worry about those. How many here?
All of them, so 5.
5, yeah. And then that, of course, is also definitional, which means that there's 1. So yeah, you're right. 2 sig figs. So this one counts and this one counts. So the only question we have to ask is, should we write this as 10 or does it round to 11? And in this case, 11. Great. So 11 grams of copper. You guys are great with sig figs as a rule, by the way. I'm always impressed by that.
I didn't like the money one, though.
That one was almost douchey because, like, it required you to represent money in a way we never represent money, right? But the point I was trying to make is money will actually be like that probably in your lifetime. Because, like, in my lifetime, now it's so dumb. We've chosen a system where, like, they don't round until they give you your money back, right? Which seems so stupid, right? Which also means that, like, sometimes if you pay cash, you pay more than somebody who pays with a card. Sometimes you pay less. Can I tell you that I'm such a math teacher that when paying money costs less, I pay with money. And when paying with a card costs less, I pay with my card. So I figure I've made probably in my life now, I've probably made a couple of bucks from the whole nickel rounding game. Because yeah, if it's going to be like 18.22, then I'm like, oh, well, that's going to cost me more if I pay, or cost me less if I pay with cash, because 2 dimes, they'll give it to me, I just save 2 cents, right? So it's cheaper. Whereas if it were 18.23, well, now they're going to want $18.25, whereas if I pay with the card, it's only going to be, so I've saved 2 cents again. So I just always pay with the method that saves me 1 or 2 cents. This is pathetic, right? But I figure, like, you do that for a whole year, you basically get a free cup of coffee. That's not a bad deal.
That sounds like when everyone she gets mad if they don't get the
Well, yeah. Well, yeah, you should be mad if you don't get the
Well, I
coupon.
mean, it's kind of like Sisyphus.
Yo, you're not wrong. That is a Sisyphean endeavor.
Yeah.
You guys know about Sisyphus?
Yeah.
Doomed for all eternity to push a rock up a hill.
Yeah.
And that falls down the hill and he just has to do it again. I like why is really up on his life is grim references. Anything in the classics that is like life is grim, Wyatt is up on it.
Yeah.
Ask me like, now if you ask him like, do you know I've got sunshines, rainbows, and lollipops? He's like, no, never heard of it. But if you're like, the world is a vampire, and he's like, do. Anyway.
Once you know the truth, there is no going back.
I don't think I could spell my name on the periodic table with decent characters.
No, that's a good question. Well, okay.
I can actually.
Yeah, because you've got V, you've got I, C. But do we have a? How do we get from T to O?
That's what I'm saying. Like,
Yeah.
there's no T, like V-I.
But is there a CT? No, there's no CT, right?
Yeah. So I literally cannot spell my name. See,
Because there's no just T, right?
Yeah,
No.
I can't spell my name.
Oh, that stinks. Can I? I never even thought. There's no J, is there? Could I do?
Yeah, I don't think.
Could I do Giuseppe? Like, could I do my Italian name, which is my given name, right? And of course, in Italian, if you want a J sound, they don't have a J. They now do. They have a J, but they only use it for foreign words. And do you know what they call this in Italian? It's great. It's so funny. Il luogo, long eye. That's the name for J.
You could probably spell it.
It's a long eye.
Whenever I think of J,
But the Italians don't use J, right? They just use a G, and a G serves both the J sound and what we would call the G sound, right? So like of jump and of Gary. Gump it is. Okay, I like that. So now the question is, how do you control that? Well, the way they control it is that if it's next to an I or an E, you get jump sound, like J, and if it's next to anything else, you get G, right? Does that make sense? Okay, great. What if I want Joe? How do you do that?
in Mexico,
Well, how they do it is they put a G and an I, and then they'd keep going. And like in my case, like that, right? So that I is not there. You don't say it. It's not like Giuseppe. It's there to just give us the soft G. Does that make sense? And what if I wanted, spaghetti? So the problem is if you just went like this, that would be spaghetti, which is not the word. So what do you do? Well, you just have to put something after it to harden it up. And so they put the H there, so that's not directly next to an E. And that's how you get spaghetti. And we may be like, well, that seems like a stupid way, but we should really shut our mouths. Because you know what we do when we put a G next to an H? Now it's an F? Really? We're going to judge the Italians? We're like, hey, you know what sound this G should make? Oh, we're brilliant. That's so smart. What a great language you've got there, English.
I mean, like,
Idiots.
I love
in
it.
Mexico, like, why do they pronounce their J's like with like an H sound?
Because they do. That's
So,
Cool.
Jose. So my name would be Joseph. Juan. Juan. I cannot do any like Spanish has such like beautiful like they like I can't oh god I can't even do a no.
So, oh my god. So,
Okay, if the pigeon brigade could settle down back
so
there.
when you speak Italian, do you not like?
I can't roll my R. Can't do it.
Roll
No.
your R's.
No, can't do it. Can't
Damn,
do it.
You should meet my grandma.
Most
She'll
I
talk to you.
know my grandpa used to give me a really hard time about it. He'd be like, God, I'd be like, yeah, I can't do that, Gramps.
Vibrate your.
I can't. I understand. Like, thank you. I understand the principle. This is like if I was helping someone with math and be like, have you thought about just being good at math? Come on, just do it. Just do the math, right? It doesn't work. You can't just tell somebody to do the thing. Obviously, if they knew how to do the thing, they'd do it. God, this is like, Which I don't do that with any students, but it is funny how anytime in my life I've tried to help my own kids with math, inevitably after like 5 minutes you're like, what don't you get? Just do it. And I think this is so weird. I would never in a million years talk that way to any other kid, right?
My
But there's something
father
about your
did
own.
that to me.
Yeah. You can't teach your own kids. Or I can't teach my own kids. It just doesn't work.
Greg.
I mean, I think I probably could at this age, but like when they're little,
It's harder when they're little.
like, and I think if
They ask
they're,
too many questions.
I'd actually be curious. I'm trying to convince Greg to take chemistry next semester because I'm just curious what it'd be like. Because I imagine if he's in your classroom, I'd just treat him like any other kid. 12.
Hesitated.
Yeah.
Rather than
I
that,
didn't
though.
hesitate.
It's like how my father somehow forgot what my exact birthday date is.
Greg's is easy. It's Christmas Eve, so that can't forget that
Oh,
one.
wow.
Yeah,
That's a lot of
that's
money.
easy.
Expensive child.
Mine's on the
That's
30th.
Every child's an expensive child. Never mind.
Wow.
Just so you know, you guys cost a lot of money. All right.
Thank you.
My dad's birthday is Christmas Eve.
Oh, there we go. It's a good birthday.
Do you know when your birthday
Oh.
is on my
But he's got a good birthday.
Yeah.
Yeah.
Do you know like any birthdays like on the 31st of December?
Yeah, my dad. No, sorry, my dad's January 1st. And my niece is January 1st. No, I don't. No one in our family is
Almost on the 30th.
When's your
really the 30th.
Yeah.
Yeah. Mine, July 26th.
Oh, you have the same birthday as my mom.
Oh, really?
Yeah.
Oh, happy birthday
I'm
to your
January
mom.
13th.
Wait, I think, yeah.
My brother and my nanny were born on St. Patrick's Day.
Oh, that's a good one. I
It
like
It was a
that.
good birthday present.
Yeah.
My brother's birthday is July 26th.
Honestly, I was
Yeah.
like,
I love it.
I was
I'll have
like
a
really
birthday.
close to being born on January.
That'd be fun. Like on like February 29th.
Summer, so
Like
bad.
I am 60 and I've only had, how many would it be? And I've only had 15 birthdays. Be weird, right?
I don't have a birthday.
No.
I
Only
just
I was born
spawned.
on a
I
Friday
just
the
spawned.
13th.
I just, I can't
But
connect. I fell from the sky.
Not a-
I hit my head too hard, which is why,
there we go. That makes sense.
When,
Okay. We gotta do another example. We gotta do another example. I do want to talk about this. I love hearing about your birthdays. I genuinely, like, I'm not saying that sarcastically, but we do gotta get through. I have 3 examples in my mind. We might only get to 2 today. I've been distractible, which
I
I'm
didn't
fine
say
with.
nothing. Well, that's close.
Didn't say nothing.
Kim,
That's a double negative.
Trying to manipulate
That's
you
a
right
double
now.
negative, and
can
of
I
course,
say this one thing?
yes.
Okay. So you know the Grinch, right? Like the Grinch movie? And you know
I am familiar with this,
you know
with
how
said
they
Grinch.
Fly in those baskets, like they send the kids and then it drops them to the doors. I used to think that's what happened to me. So I asked my mom, I'm just like, is that how I came to you? And she'd be like,
Looking at you.
no.
And she'd be like, no, actually, I
Yeah.
pushed you out of my body. It is an incredibly painful
she'd be like,
and
"You came
uncomfortable
from my
experience.
stomach."
But thank you for assuming that it was that easy, kid. I'm just saying.
So I thought
Do you know what I do on my birthday every year?
baskets.
What?
I used to always work because I hate being the center of attention outside of my job.
Birthdays are like
And
highlights.
and then I always send my mom flowers with a thank you note. You know why? Especially now that I'm married to a midwife, I got news for you. Celebrating your birthday like you did anything? What did you do? You moved like a foot and then you cried a little. And then they wrapped you up, and then for the next year and a half of your life, every time you went to the bathroom, you were like, clean me! But you didn't even have the decency to say it in English. You'd just be like, "Meh," and then they had to come do it. So listen, on your birthday, why not celebrate the person who did the hard work? Send your mom a thank you card.
Reality
Do
is
you
not
really
the
have to
point.
though? Because
If you don't know your
never-
mom.
Then internally think, hey, person who I don't know, who never did anything else for me maybe, at least he did one thing for me, which was push me out in a painful manner into this world. Thanks for that.
Well, the-
Talk to you never.
Up fast.
Joe out. Right? Like, seriously.
Joe
Nah,
out.
that's the thing though. You never asked them to do that. Hey, my mother didn't know she was having me until she was 7 months pregnant.
What?
Yeah.
That's wild.
Wow,
I
you're
worked
special.
I worked with a girl who went to the doctors one day because she had an upset stomach.
Oh.
She came home with a baby. Can you imagine?
How do you not know?
Can you
That's
imagine?
9 months.
Oh well, there's actually no. There's
Like, that's
No,
wild.
I forgot what it's called.
Like, that's wild.
I think there's something called a.
It's terrifying.
No, there's actually a
Terrifying.
pregnancy like that where you don't know.
Yeah.
Yeah.
And she was like she was little, and she had been like she had grown a little bit, and she'd been feeling like, oh, am I having like intestinal issues or something? You know, because she had like a little thing, and then what she had was a friggin' child. She had no idea.
A girl
She
or
didn't,
boy?
she didn't have like a little girl. She didn't have like a nursery. She didn't have any, like, that's terrifying.
That's crazy.
Terrifying. She didn't have a car seat. I remember she phoned my boss, Wendy, and was like, does somebody have a car seat? And Wendy was like by this point she'd heard, she was like, we will find you a car seat. But it was just like the practical things, right? Like,
Yeah, but
oh God, just thinking about it, terrifying. Anyway, example 2. All right, let's take a look here. In this case, we're going to find the concentration of a final solution. Concentration of a final solution. Okay, so let's say, hypothetically speaking, that this time we take
Rubidium.
we take 3.6 grams of aluminum react with a perfect amount. In other words, exactly the right amount of copper chloride. We're going to stick with Cl2. In 0.085 liters of water. Oh, sorry. I had these numbers in my head, but I grabbed from the wrong one. This was going to be 1.2. In 1.2 liters of water. What is the concentration? Why didn't I just put it in there? AlCl3 after the reaction. And as you can see, when we start this off, I'm starting with nice, like easy numbers. Or not even just easy numbers, but nice, easy situations. No limiting reagents yet, right? I'm just saying we have enough. We have too much. We have excess. Down the road, of course, we'll get to slightly more complicated versions, but you'll be ready. Does that make sense? It won't stress you out.
What is perfect in that thing?
I just mean I'm not going to have any left over, and I'm not going to run out. Does that make sense? Whatever the perfect balance is, so we had exactly the right amount of aluminum and exactly the right amount of copper chloride, we weighed it out. And I had Victoria do it, so I know it's good. She sat there and did it just right. Like, it's real good.
She read off her book while she was doing it?
Yeah, she told the aluminum all about it. She was like, and the aluminum was real into it. Can I say, I am not making fun. I love your book recaps. They make me really happy. And I seriously, you bring me the first book in that series, I'm going to read it because I'm secondhand into it now. You know, like when a friend tells you all about, it's like, you ever have a friend who makes a new friend who you haven't met yet and they keep telling you all about this person? You feel like you know them. Has this ever happened to you? And then you meet them and you're like, sometimes you're like, oh, not what I expected. But sometimes you meet them and you're like,
I know.
You know their whole
like,
life.
well, not only that, but they also like are exactly how you pictured them, and you're like, yep, got it, and you just go. It's like, boom, now I am also your friend because we skipped all the getting to know you stage because I've just had this.
You already know them.
Have I ever told you guys about Dodie Bresner?
Probably, but
Since we're getting
I'll bring
distracted
you
today,
up
my buddy Chris, my best friend Chris, his brother Tom is a pastor. Right, so he's a pastor. He lives in St. Catharines now. Actually, no, sorry, he's a pastor in Welland now. Actually, but for a while he's part of a group that went and they were starting. Then their whole thing is he's a Mennonite, which I don't know how much you know about Mennonites, but their whole thing is sort of they believe in like sort of whenever they start a church, they try to find something in the community where the community has a need, and they try to fill it. So, for example, in St. Catharines, he was part of a church that started there, and they started a homeless shelter, Southridge Homeless Shelter. My sister actually works there. And the goal is to build something that, like, outside of the religious element of the church, something that just serves the community, that finds a need and fulfills it. And whatever your feelings on the religious beliefs, if every religious organization took that tack and said, hey, let's find something in our community that really needs to be done, and do it for everyone, not just people who agree with us, not just people whatever. Be a pretty beautiful place. So anyway, Tom's a really good guy. I really like him. But he was starting this church in Calgary, and so they were like, but he was a consultant. Like he was going up. Like he wasn't going to work there forever. He was going there for like a year to help them get started and help them like with the like managing the construction and all these things. So he gets there, and it's like there's a whole bunch of people there who've just met each other recently, and all of a sudden they're hanging out a lot, right? Because for like the next 6 months they're going to be working together a lot. So he makes quick friends with this other guy, this guy named Drew, and they hit it off quickly and they get going. And they're both jokesters. And my friend Tom is a lover of pranks and practical jokes. I've got a million amazing Tom prank and practical joke stories. But this is maybe my favorite because they just thought it would be funny to like keep talking about this other person who's part of this group that didn't exist and like just always talk about it. So they invented this guy, Dodie Bresner. And they'd be, hanging out after work, like, having a beer at like Boston Pizza and saying like, oh, hey, that was so funny earlier when Dodie was telling us a story about like what happened. They're like, sorry, when who? Dodie. What? Dodie Bresner? Like, he works like he's doing like construction coordination. Ron, you sat next to him last week at when we went to Kelsey's, and everyone would be like, what? He's like, yeah. And so they just kept doing this for weeks. And the goal was to finally get somebody else to talk about Dodie Bresner. And like, so people would start doing it. They'd be like, but at first they did it in a perfectly like honest way. They'd be like, oh, by the way, like, can you invite Dodie? I don't have his number. And so eventually it got so out of control that I think they had like a burner cell phone, which is Dodie Bresner's cell phone. Anyway, long story short, it ended with somebody being like, yeah, I was hanging out with Dodie last week. And they're like, no, you weren't. They're like, no, really, we were. We went out for dinner. He's like, nope, pretty confident you weren't. And they're like, what do you mean? And he's like, there's no Dodie Bresner. We made him up. He's not real.
And who is she?
And this, well, exactly, right? So the person lied
like
just to
drama
fit in.
show?
Anyway, let's get to it. So, nope. Okay, so first, before we can do anything else, we need what? If you're going to do chemistry, you need a balanced equation. So here we have aluminum. What's symbol for aluminum?
AL.
Yeah. Whoa. They work in blue. I haven't done that in a while. All right, we have aluminum, and it's going to react with same thing we just used, just to keep life easy, CuCl2. This is yet another of what kind of reaction? Single displacement. So it's going to be by itself over here. Copper again. But this time, aluminum and chlorine are going to go there. Now, normally you'd have to go to the side and figure out what the formula that's going to be, but I gave it to you in the question, which is awfully kind of me. So aluminum wants to give away how many electrons? 1, 2, 3. Et combien d'électrons est-ce que chlorine get? Not baguette, but just get. Chlorine can only get 1 electron, so aluminum needs 3 chlorine, so we get AlCl3. There's the reaction, but of course, what isn't this reaction?
Balanced.
I know how it feels. So how do we fix that problem? Yep. Okay. That's a start. It's going to break down a little bit. How many chlorines do we have here now? 2 times 2 is?
4.
Yeah, the problem is not 2 here, but... You're still close. Not 2 here, but 3, which means obviously this needs to be a 3. And then, of course, now this is 6. And, of course, to make this 6, what do we need in front? 2. Yeah, very good.
And then you need...
And then to make this 2, we need 2. All right, so 2, 3, 3, 2. One of the classic balancing patterns. And these ones get sneaky, right? But good job. By the way, copper is going to be a solid. It doesn't dissolve in water. Aluminum is going to be a solid. That copper chloride would have dissolved when it was put in. And this aluminum chloride will also dissolve. All chlorides dissolve. Chlorides are just soluble stuff. There's a few exceptions. Aluminum isn't one of them. Okay, we have a reaction. But now, let's start where we're going. We're starting with grams of aluminum, right? And we want to end up with the concentration of aluminum. With the concentration of aluminum chloride, right? Does that make sense? Well, let's go back to our map. How do I go from grams of one thing to concentration of something else? This is not going well. This is not going well at all. that was awful.
So you need to find the moles of that thing, and then from that you can find the concentration weight.
Yeah, so we want to go from here, grams of one thing, to concentration of something else. That makes sense? Because it gave us grams of aluminum, and it wants the concentration, molar, of something else. So how do we get from grams of one thing to molar concentration of something else? I'm going to go from grams to...
moles.
Okay, what am I going to have to look at to do that?
The periodic table.
Cool, periodic table. And then from moles, I'm going to go where?
The concentration.
Can I do that directly? Whoa.
Oh, down there.
Yeah, I'm going to have to go from moles of copper to moles of aluminum, rather, to moles of aluminum chloride, right? Then, once I've done that, I can go from moles of aluminum chloride to moles per liter of aluminum chloride. Does that make sense? Grams to moles of the thing I actually want to know about, moles to concentration. So grams to moles, because we do chemistry in moles. And then aluminum isn't what I want to talk about. I want to talk about moles of aluminum chloride, right? And then we can go from moles to molar, right? Which is another way of saying moles per liter, right?
So we want to start off like with a fraction, right?
Ah. Is he good? Is he good? He's good. That's right. That's right. But the only thing to note, just as I was going to say, is that this is a fraction. So even though this isn't a fraction, start with a fraction and put this on the top of it. Oh, you're good. Man, you're good. So let's just do it. We start with a fraction because we want to end with a fraction. And on the top of a concentration fraction always goes stuff, right? And at the bottom always goes liquid, right?
Yep.
So stuff, well, we know where we're starting. We're starting with grams of aluminum. So there's our stuff. How many grams of aluminum do we have?
3.6.
Great. So let's start with 3.6 grams of aluminum. How much liquid do we have?
1.2 liters.
1.2 liters. Now, the nice thing is, if you look at this, see this liter down here? We've already got it where we want it. So we've got half of our units taken care of. Does that make sense? We need moles per liter. Well, moles of aluminum chloride per liter. Well, I don't have moles of aluminum chloride, but I do have liters. Does that make sense? Halfway there. So now, let's just get going. How do I go from grams to moles? What do I look at? I look at the periodic table. All right. So what unit don't I want? I don't want grams of aluminum. I do want
Moles.
of?
Aluminum.
Awesome. How much does a mole of aluminum weigh? I know the periodic table tells me how much one mole weighs.
26 point, like 27, I guess.
I'm getting, we could do 26.99.
Right.
Actually, it'd be 98. Okay, 26.98 grams. Good. What units cancel here?
The grams.
Yeah. What units haven't canceled?
Liters.
And?
moles.
Yeah, so we know how many moles of solid aluminum we have for every liter of liquid, right? Is that a useful number in itself? Not really. But that's okay because we're not done yet, right? Next step, we need to take those moles of aluminum and turn them into?
Moles of AlCO3.
Good. So where do I put the moles of aluminum?
Bottom.
So the moles of aluminum. And on the bottom, we'd put moles of, sorry, at the top, we'd put moles of AlCl3. And where do I get those numbers?
No, balanced equation.
The balanced equation. Very good. And let's look at our balanced equation. How much aluminum in this equation? Solid aluminum. 2 moles of solid aluminum. How many moles of AlCl3? 2. Very good. And what units cancel?
Moles.
Yeah, moles of aluminum. And now let's just look, because I think now we just have to calculate, right? And we'll have the answer. Because what's on top? Moles of AlCl3. And what's on the bottom? Liters. So we have moles on the top and liters on the bottom, which is moles per moles per liter. And what do we measure concentration in? Moles per liter. That's all. Okay, so let's see if we can do this. This is actually a trivial one. 3.6 divided by 1.2 is 3 exactly. That's 1, that's 1. So what we have is 3 exactly divided by 26. Oh, God. Well, if we said that was 30, which it's not, 3 divided by 3 would be 1. 3 divided by 30 would be 0.1. This is going to be a little bigger than that because that's less than 30. So this is going to, and how much less than 30? Give me a sec. 27, which is 3 short of 30, which is 9 out of 10. So what is 10 divided by 9? This should be like 11.1. I got this. Is this like 0.11?
Yeah.
Yeah, very good. 0.1111 and so on and so forth. And then we have 2 sig figs, so we can just round it to 0.11. And what's our unit? Well, it's moles of AlCl3 per liter. Or how else could we write that? Or we could say it equals 0.11 big old M AlCl3, right? It's not too bad, is it? Right? Bit of practice. It's not so bad. I'm going to leave it there for today, which leaves you a bit of time. You can use that free time to do whatever you want. I'd prefer that you be constructive. That's fine. Because I don't want to bash your head around with this. We're going to do some more of this tomorrow. Similar to how we looked at dilutions, right? We did it. We did a lesson. We wrote it down. And then we almost did another little mini lesson yesterday, right? Which I'm sure was enthralling and wonderful. Was it enthralling and wonderful?
Yeah.
I heard they had some technical issues. I apologize.
No, you'll probably get the book tomorrow. But I want you to...
I marked you out. I wasn't here.
No.
He did. Good. Keep you on your toes.
But I want you to know something.
I want you to-
that you have to take this quite seriously. If that book...
Victoria, is that facing the same way as all the other ones? Well, if that one was doing heroin and jumping off a bridge, would you also do heroin and jump off a bridge?
I want you to check if
What? I'm just saying that if just because your best calculator friend is doing something doesn't mean you have to.
Yeah. Anyways, like I was saying, just saying, if that book comes up scratched or hurt, you will lose a leg.
I'll lose a life or a leg? Leg. Which one?
Doesn't matter.
Which one's more
Well, matters to me.
Which one's your dominant?
Surprise.
Leg surprise. The worst thing on the menu. I'll take the leg surprise, please. And then Victoria just runs out and chops off one of your legs.
Dominant one.
Am I right?
I want you to check.
Kiss it goodbye.
I
Okay,
want
first of
you
all,
to-
no interest in kissing my own leg. Second of all,
I mean it in the most respectful way possible because the
I
book
don't.
is like my child. It is my child.
no, I get it. I have a guitar that's like one of my children.